Hey guys, this is your video for Chapter 1, Unit 5, Part A. This video is going to be talking about cube and cube roots of numbers. So again, just similarly to when we were doing square and square roots, I want you to actually think of the shape itself. So a cube is a three-dimensional figure. So it has length, width, and depth, right? So it has, again, 3 dimensions going on instead of 2 like a square does. So because it has 3 dimensions, now we're thinking we've got 3 numbers that are all multiplied by itself in order to get the cube of a number. So again, think of a cube. So here we have a physical cube. And now a cube is like similar to a square in that all lengths are the same size. So that means the length, the width, and the depth are all the same length. So this cube itself here has a length, a width, and a depth of 2 centimeters. So that means to find the volume, so instead of area like a square, I'm talking about volume for a cube is going to be my length, my width, times my depth. So I'm going to do my 2 times 2 times 2. And it's 2 times itself. It's that same number times itself 3 times. So I would write that as 2 to the 3rd power, or 2 cubed. It's saying, hey, I have a cube. Each length of the side is 2. So again, you can write it as 2 cubed. So this 2, that is my base. The 3 is my exponent. Okay. A perfect cube is very similar to a perfect square when the length of your square is a whole number. A perfect cube is when the length, width, and depth of your cube is a whole number. So we're not working with fractions or decimals. Can you? Yes, but is it going to be a perfect cube? No, it's not. So yes, let's move on. So here it's saying find the cube of each number. So it's saying, hey, if I have a cube, so a 3-dimensional figure, that's a terrible cube right there. So I have a 3-dimensional figure, and this is saying the length, the width, and the depth are all each 5. So this is 5, this is 5, and this is 5. So it's asking, what is the volume of this cube if the length of each side is 5? So that would be 5 times 5 times 5, which I can also write as 5 to the 3rd power, or 5 cubed. So this is where I would do 5 times 5, which is 25, and 25 times 5 is 125. So the cube, 5 cubed, is equal to 125. For 6, same thing. So that's saying if I have a cube and the length of each side is 6, it wants me to find the volume, how much space the cube takes up inside. So that's 6 times 6 times 6, which is 6 to the 3rd power, which would be 6 times 6 is 36, and then you'll do 36 times 6. And if you don't know that, come off to the side and do 36 times 6. And again, 6 times 6 is 36. 6 times 3 is 18. Plus 3 is 21. So then my cube of 6 would be 216. Okay. And the next one here would be 9. I'm going to clear that off so I can see a little bit better. So that's saying, what is the volume of a cube if each length of the side is 9? So that would be 9 times 9 times 9, which I could rewrite as 9 cubed. And I'm trying to figure out what that is. So I know 9 times 9 is 81, but do I know 81 times 9? Nope, not off the top of my head. So I'm going to do 81 times 9, and that's 9, and that's 72. So 729 is my 9 cubed. And very similarly to when we did square and square roots, now we're finding the cubed root. So it's going to be giving us the volume of the cube, and we need to figure out the length of the side. So this right here is saying, hey, if the volume is 27, if the whole thing is 27 meters squared, I need to figure out the length of just one of my sides. I need to figure out what the length, the width, and the depth would be. And we're going to write that using our radical sign here, just like we did for the square roots, except I'm going to put a 3 there, indicating that I'm looking for the cubed root of the number. So I'm trying to find the cubed root of 27. Now, how we do this, we can do math facts, right? So thinking off the top of your head, okay, you could do some guess and check. You could do, well, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. That's not enough. Let me try 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. That's too much. And so I'm going to go back, right? I can also think like, well, what goes into 27? 3 does, right? So I could think, well, maybe it's 3. If I do 3 times 3 times 3, 3 times 3 is 9. 9 times 3 is 27, so that checks out. So my cubed root of 27 would be 3. So your math facts are really going to come into play here. If you don't know your math facts, you could also do your prime factorization, and this is where your prime factorization is really going to help out. So I know 3 times 9, and I do 3 times 3. Again, it needs to be split up into 3 equal groups in order to get to 27. Well, there's my 3 equal groups, 3. So again, my cubed root of 27 would be 3. And let's try some other ones here. And this is where they're showing you the prime factorization. And I want to point this out. If you want to find 64, the cubed root of 64, you do your prime factorization, so you're going to end up with 2, 2, 2, 2, 2, 2. I need to split them up into 3 identical groups in order to get to that 64, because it's 3 identical things multiplied together to get to 64. So look, I'm going to split them up into 3 identical groups. Each group has 2 times 2 in it, so that means 4 times 4 times 4 is going to get me 64. So my cubed root of 64 is 4. Okay, whoops, sorry, I keep clicking out of that. Okay, so let's look at a couple of these. I'm not going to do every single one just so we can sort of get the idea though. Let's look at, let's do 216 first. Okay, and so we're going to do our factorization, our prime factorization, and I'm going to do 2 and 108, and I'm going to do 2 and 54, and I'm going to do 2 and 27, and then I'm going to do 3 and 9, and I'm going to do 3 and 3. So right here, 2 is prime, 2 is prime, 2 is prime, 3 is prime, 3 is prime, 3 is prime. I need to split it up into 3 identical groups in order to get to 216. So I'm going to take a 2 and a 3. They can pair up. And I can take another 2 and another 3, and they can pair up. And then I can take the other 2 and the other 3, and they can pair up. So each identical group has 2 times 3 in it. Well, 2 times 3 is 6. So I know then that the cubed root of 216 is going to be 6. Okay, I'm going to, let's see, I'm going to go to 1,000, and then we'll stop there. So for 1,000, I can do 2 and 500, and 5 and 100, and 2 and 50, and 2 and 25. And again, it doesn't matter exactly how you do this as long as you get to the same answers. We've got 2, 5, 2, 2, 5, and 5. Again, I need to split up into 3 identical groups. So a 2 and a 5 can go in each group, right? So now 2 times 5 would be 10. So I know that 10 times 10 times 10 is 1,000. So I know my cubed root of 1,000 is 10. I'm going to stop there for the regular classes. Honors classes, here's a little extension for you. So we can do the roots of more than just squares or cubes. We could do quad roots, we could do fifth roots, and it's all going to be the same thing. So just like we were doing when we did the cubed root of 1,000, right? And we broke it down into 3 identical groups. If we were to want to do the quad root of a number, I would do my prime factorization. So do your factor tree. and figure out how you can group your prime numbers into 4 identical groups. That's if you're trying to figure out your quad root, okay? Or if you were trying to figure out your 5th root of a number, you do your prime factorization, and then how could we break those numbers up into 5 identical groups? So we're going to be doing some of those extensions, hopefully, in class if we have a good grasp on the cube root. So I hope that helps, and I'll see you guys later.